What's up, guys? Welcome back. Patrick here, and in this video we got to simplify and state restrictions for these three expressions over here. So starting with number one, we got 4 over 3x to the 3 y squared z to the power of 3 minus 1 over 4x y to the 3 z squared plus z, this is a z over here, not a 2, over 6x squared y squared. So as we did in the previous examples, we're going to follow those same general steps. So first thing you want to do is see if you could factor anything, and notice everything here is factored. So we're all good on that step. Second step, we want to get restrictions. So basically, what values would make the denominators equal to 0? So notice that with all of these, basically x cannot equal 0, right? Because if x is 0, it would make this denominator 0, this denominator 0, that denominator 0. Notice that y can't be 0. That's another restriction. And then notice that with these two, z can't be 0, because it would make these denominators equal to 0. There's no z over here in this denominator, but it doesn't matter. As long as one of the denominators has that expression, then it counts as a restriction. So z cannot equal 0. Those are the three restrictions in this case. And now we could simplify. So with this one in particular, what's the lowest common denominator going to be? So let's look at the numbers first. We got 3, 4, and 6. What's the lowest common denominator between those three numbers? It's 12. Now, what's the lowest common denominator between x to the 3, x to the 1, and then x to the 2? It's always going to be the highest exponent, right? So the highest exponent between 3, 1, and 2 is 3. So x to the 3 is going to be the lowest common denominator between x to the 3, x to the 1, x to the 2. Now let's look at the y's. You've got y to the 2, y to the 3, y to the 2. So y to the 3. 3 is the highest exponent. Then we've got z to the 3, z to the 2. There's no z here. It's almost like there's a z to the power of 0, which is like 1. And the highest exponent between all of these is this 3 over here. So it'd be z to the 3. So that right there is the lowest common denominator between these expressions. And now we got to figure out, what do we have to multiply each of these by to get that? So starting with this, notice the 3 we're going to have to multiply by 4. X to the 3 is already there. Y squared, to get to y3, we're going to have to multiply by y. And then z3, that's already there. So we're going to have to multiply this by 4y to get that. Another way, you could take this, divide it by that, and it would simplify to 4y. So we've got to multiply the top by 4y. What do we have to multiply this by to get this? 3x squared z, right? 3 times 4, 12. X to the 1 times x to the 2, x to the 3. The y to the 3 is there already. Z to the 2 times z to the 1 gives us z to the 3. So we got to multiply the top by that same amount. And then this here, got to multiply this by 2 x, y, z to the 3. Right? Yeah. 6 times 2 is 12. X to the 2 times x is x to the 3. Y to the 2 times y. Y to the 3. Then z to the 3 to get that. Meaning we got to multiply this top here by that expression as well. Okay, so from here, these are the three restrictions. I'm going to erase these. I'm going to combine this into one. So what's going to happen here, this times that is 16y. This times that plus 3x squared z. Plus this times that, the z's would multiply and it would become z to the 4 up top. So we'd have 2x, y, z to the 4 all over that lowest common denominator, which I erased, which was 12x to the 3, y to the 3, z to the 3. And remember, what you want to check at this point, this is the simplified version. but you also want to check, can you factor anything out? And notice that from the numerator, can't factor out any numbers between 16, 3, and 2. Can't factor out any variables. There's a y here, there's no y over here. There's no x over here, and there's no z over here, right? And then this is just one term in the denominator, so can't factor that. So this is the final expression with those restrictions. X, y, and z cannot equal 0. All right, so that's the final answer for number 1. Now, number 2, first step, factor. Everything is factored here. Now we get the restrictions. So notice x minus 4 cannot equal 0, which means x cannot equal 4. And then 2x plus 1 cannot equal 0, which means x cannot equal -1 over 2. Those are the 2 restrictions. And now we simplify. Notice x minus 4, 2x plus 1, those are completely different factors, right? This doesn't go into that, this doesn't go into that, so we've got to multiply them together. So the lowest common denominator would be x minus 4 times 2x plus 1. So we've got to multiply this by 2x plus 1. Got to multiply this by x minus 4. Sorry, we have to multiply the bottom by 2x plus 1, and then this by x minus 4. So if we rewrite this, we'd have 6 bracket 2x plus 1 plus 4x minus 4, like that. Right? So took these 2 expressions, combine them into one. Now what you want to do, you want to simplify that numerator. So we'll have 12x plus 4x gives us 16x. Then we'll have 6 minus 16, which gives us -10. Right? That's going to be all over x minus 4 times 2x plus 1. Let me just double check that that's all good. Yeah, it looks fine to me. So 6 minus 16 gives us -10. And then from here, you're not done yet. You want to factor again, because something may cancel out. In this case, we could factor out a 2 from the numerator. So we'd be left with 8x minus 5. And then nothing cancels out in this case. But a lot of times, not a lot of times, very small amount of times, but you may run into a situation where 2 brackets can further cancel out, where you couldn't see that before, but then at the end they would cancel out and you could simplify even further. But in this case, this doesn't simplify, so this here ends up being the final answer with those 2 restrictions. And then finally, number 3, exact same steps. You want to see, is everything factored? Yes, it's factored. Then get the restrictions. So basically 3x minus 1 cannot equal 0, which means x cannot equal 1 over 3. And then 2x minus 3 cannot equal 0, which means x cannot equal 3 over 2. Those are the 2 restrictions. These are totally different expressions. So we're going to multiply them to get a lowest common denominator. Multiply this by 3x minus 1, top multiplied by 2x minus 3, this multiplied by 3x minus 1. So if we combine everything, we would have 5 bracket 2x minus 3 minus 2x 3x minus 1 all the way over 3x minus 1 times 2x minus 3, like that. Right, so combine them all into one expression. Now from here, what we want to do is simplify. So distribute. So notice the -2x times 3x, that would give us -6x squared. Then we're going to have 10x. -2x times -1 is positive 2x. So 10x plus 2x gives us 12x. And then 5 times -3 is -15. All over 3x minus 1, 2x minus 3, like that. And then you want to see if you can continue to factor. And notice that we can. We could take out a negative 3x. Let's see what this factors into, this negative 6x squared plus 12x minus 15. I'm going to do that on the side here. So notice I could take out a negative 3. So we'd be left with 2x squared minus 4x plus 5. Right? Yeah. Looks good to me. And then from here, what you want to do, you want to see if this quadratic factors, and then taking the 2, multiplying it by the 5, we would get 10. What two numbers multiplied to 10 add up to negative 4? There are no two numbers where that would be a smooth factoring process. And so this here actually doesn't end up factoring. And so the final answer would either be this or basically this over that same denominator. Let's erase that. Right, and then this quadratic here, that doesn't factor any further. But a lot of times this quadratic can factor further, and sometimes factors can further cancel out. In this case, nothing cancels out. So either this or this are the final answers. And then those are the two restrictions.